So I'll go ahead and if one of you guys want to give it a shot, feel free to give it a shot. Otherwise, I'm going to go ahead and just start walking through the first solution for this. Let me give you the live share link so you could actually hop into the code editor if you would like to. And so the way I'm thinking about it, and let me just comment out this first test case here. And so if we take this first test case, we want to iterate from 1 to 22, checking every integer from 1 to 22. So we want to check 1, we want to check 2, 3, 4, all the way up to 22. Now, I know that I need an output array, right? Because we're taking one of our parameters is left, it's a number. The other parameter is right, it's also a number. So we have those. But then what are we outputting? We're outputting an array that contains numbers. And so what I need, let me look at the output here, just so I can see what the output is supposed to look like. So it's supposed to look like this. And so the first thing I'm thinking is just like loop, because I have to go from 1 to 22. And in the second one, I have to go from 47 to 85. So the first thing that comes to mind is just loop, because I want to iterate from 1 to 22 in this one. But in the second one, I want to iterate from 47 to 85. So just like the fact that I have to move from one number to another number just screams loop to me. But as I'm iterating over these numbers, so 1, 2, 3, 4, 5, I need to check, is this self-divisible? Is this self-divisible? Is this self-divisible? So inside the loop, I need to check if it's self-divisible. So let me just put check is self-divisible. And if it is, exactly, push into output array. So if I'm pushing into the output array, I know I need an output array. So let me initialize output array here. Oops. And then this is basically the logic of the code here. At the end, I just need to return result array. Oops. Return result array. The thing we need to think about now is like, how do we check if it's self-divisible? Because we have all the logic. Now, how do we check if it's self-divisible?
If there's no remainder, it's divisible by itself. So the fact that there's a modulo symbol in the example kind of gives me a hint.
Exactly. Exactly. That's a good point right there. So yes, we are going to have to run the modulo on each number that it contains. So there's two ways that I thought of doing this. One of them is, let's just say that we've iterated over 1, 2, 3, 4, all the way up, and now we're at 22. So one way of doing this is converting this to a string so that I could actually iterate over the string, because if it's a number, I can't iterate over it. If it's a string, I can iterate over it, and for each character, I can parse it as an integer, and I could divide our original number by the parsed integer. And if at any point it is, if our original number, so let's say 22, for example, in this case, modulo our parsed integer does not equal 0, we could just return false. It's not self-divisible. One other case that we need to check out for is if it's equal to 0. So it can't contain the digit 0. So if at any point our digit is 0, we just want to return false. If it makes it through the loop of our string from our first character to our last character, and it passes every time, so the character is not equal to 0, and our original number modulus our digit or our current character is not equal to 0, or it is equal to 0, so it's divisible, for example, then we'll return true. So I actually created a separate function for this. I'm just going to go ahead and say const is self-divisible. And I'm passing in the number. And the first thing I want to do is convert the number to a string. Then I want to iterate over each character of the string. I want to initialize the current character as an integer with parseInt. And then I want to check if digit is equal to 0, and I want to check if our number that we passed in is divisible by our digit. If this is true, I'll just say not. If this is true or this is true, we just return false. Otherwise, if we make it through this entire function, we just return true. And we know that this number that we passed in originally is divisible by every single one of the characters it consists of. So if we pass in 22, we convert it to a string. We check if it's divisible by 2. We check if it's divisible by 2. If it is divisible by both of them, we end up returning true because we never return false, because neither one of these characters is equal to 0, and also 22 is divisible by 2, and 22 is also divisible by 2. So if at any point we encounter a character that is not divisible by 22, then we just return false. And so that's the first method there. Let me go ahead and just copy all of this really quickly and put it over here. And just instead of converting into a string, I want to show you a different way of doing this. Now I'll let y'all go ahead and type some code so you can actually get your hands dirty. So let's assume we have 122. So if I want to do this without having to convert it into a string, which could end up being more efficient, I want to just take this last digit off of 122. But I also need to maintain a copy of the original 122. So I store our original 122 in a variable called original, and then I do work on the number that's passed into the function. So similar to the number that's passed into the function here, I do some work on this right here. And the way that I pull the last digit off of this 122 is I just do 122 modulus 10. If I do 122 modulus 10, it's going to give me the last number. So 122 modulus 10 is going to be 2. And so that's going to be my digit. So I could say digit equals 122 modulus 10. It's going to store 2 inside of there. Then I actually want to modify this number here because I want to take 2 on this one, but on the next one I want to take this. On the next one I want to take this. And so to change 122 to actually just 12, because I'm already using the 2, so I don't want to reuse it again, then I do just num equals 122 divided by 10. But if I do this, it's going to give me 12.2. So I want to do math.floor. That way it'll chop that 0.2 off and it'll just return 12. So every time I run this, I'm going to be able to target the last number in our integer. And then I'm going to be able to cut off the last number in our integer. So on the next one, it'll be 12, 12, and 12. So the digit on this one would also be 2. And then when we run this code right here, we chop off that 2 and it become 1. And then 1 modulus 10 would be 1. So we do that. 1 divided by 10 would be 0.1. Math floor would be 0. And so we want to do this until our number is 0. So while num is greater than 0, basically do all this stuff. Let me go ahead and, so it's basically the same, just instead of converting the number to a string, we are storing our num inside an original num identifier or variable. I'll say variable, because we need a reference to our original number, because we're actually going to be modifying number. We're going to be chopping it up basically. So we want to keep a reference to our original number so we could continue to do that calculation. Then we do want to iterate over it, but instead of iterating over a string, we're just doing while the num is greater than 0, because once it comes to the point where it is 0, we know we've chopped off every digit and there's no more to divide. And then we're basically going to do this logic over and over. So this right here, the check, is going to be exactly the same. Just instead of checking if number is not divisible by a digit, we're checking if original number. So the reference is always going to stay the same. It's going to be, if we pass in 122, this original number is always going to be 122 as we modify num and chop it up. And we're checking if it's 0. And then the only other thing we're changing is we're not going to have to convert our digit into an integer with parse int. We're actually just going to store last digit of num in digit variable by executing num modulus 10, and then modify num or chop off last digit of num by dividing by 10 and flooring. So that's the other method right there. So I don't know if you guys want to each choose one of these to go ahead and just type it out. If you have any trouble or have any questions as far as like syntax go, you could feel free to Google it or just ask me. I can help you out. As long as you're asking the question, I feel like that's the important thing. And then we should have enough time to go over the third one. The third one is just where this is a very small problem. It only goes up to 10,000. And so on the last one, I actually just build an array called pre-computed self-dividing. And this array contains every number that's self-dividing from 1 to 10,000. And so it takes up a little extra space, but it actually turns it's O of 10,000 time complexity the first time you run it, but every time after that, it's O of 1. So you do a little extra computing in the beginning. You do like worst case scenario in the beginning, and you do take up a little bit of space. Worst case scenario, O of 10,000, but we know it's not O of 10,000 because every number from 1 to 10,000 isn't divisible. So it's however many numbers are divisible between 1 and 10,000. And then, so you're taking up a little extra space, but it makes sure that the time complexity is O of 1 every time you execute. Every time you pass a left and a right in, it's O of 1, which is like, man, if you could use a little extra space and do some pre-computation to ensure every computation afterwards is O of 1 time, that's like, yeah, that's why Google is Google, you know. So yeah, feel free to go ahead and give these a shot. There's 2 of them, so it's perfect for you two. I'd say the string is a little simpler than the one with the computation, but they're both pretty straightforward. So yeah, and then whoever does the second one, the one with the computation, we're going to be using this computation in the third one. So yeah, take a few minutes to give it a shot. Let me know if you have any troubles, and yeah. You can if you want, or you could just work in file 1. It's up to you. Yeah.
inside of a while loop?
Yeah. Yes. You will only be able to access it inside that block if you do though. Which is cool. Yeah, for this problem. That's good.
Are we actually dividing by 10? Or are we using modulo?
Store last digit of num in digit variable by executing. Yes, so you're on the first one, yes. If you do num modulo 10, it's going to give you the last digit of that number, basically. Yeah, because let's say, for example, you're...
And not
yeah.
divided by 10.
If you divide by 10, let's just say, for example, your number is 122, it's going to give you 12.2. So that's not going to give you the digit you need. To get the digit you need, you want num modulus 10, because num modulus 10 is going to give you the remainder of 122 divided by 10, so that'll be a remainder of 2. So num modulus 10 is always going to give you the last digit of an integer. Int I would be like C. You want to do let in JavaScript. Yep. And you basically want to initialize I as left. You want to start from I and go until right. So whatever left is, that's what you want to initialize I is, and you want to continue iterating over the loop while I is less than or equal to right.
Would I be flooring this all in one go, or do I need to create something separate to floor this?
This is good. This is good right here. Yeah, because you just want to pull the last digit off of the number. So for example, your number is 122. You do 122 modulus 10. That'll give you 2.
Doing math.
No, you don't have to floor it.
No.
No. Because let's just say you have 122 and you modulus 10. That's going to be 2. Let's say you have like 343 modulus 10. That's going to equal 3. If you have like 5,555 modulus 10, it's going to equal... What's it going to equal?
5?
Yes, exactly. So whatever number you have, if you do modulus 10 to it, it's just going to chop off the last. It's going to give you that last one. Because if, let's just say you put a 0 at the end of all of these and you modulus, it's all going to be 0. So whatever the last digit is, modulus 10 is always going to give you the last digit. So that's what you want, because we're gonna take the last digit, and then after we have that last digit, so you store that last digit in digit, then you're gonna do the divided by 10, which this would be 126 divided by 10 would be 12.6, and in this case, that's when you want to floor it, because you want to chop that 6 off.
Okay, I'm just like now figuring out how to express that using digit. Okay.
You're not using digit for that. So this first one is just get the digit. This second one is modify num. So change num. But you're not using digit to modify the number. So actually, let me just give you this code, because this code goes inside the for loop too. There you go. So as far as like what you have so far, that's good.
Yeah, it's just the continuation that I'm now like, what?
Yeah. Yeah, so this is just to get the digit. This line of code here is going to be to modify number, and then you're actually going to use digit down here in the checks. This line is only so you're prepared for the next go around. If that makes sense. For the next iteration.
So, am I just literally saying num equals math floor of something?
Yeah. Yep.
Well, math dot floor of what now?
So let's say your number is 122 and you want to get 12 from that. What are you doing?
Wait, is that?
So you want to convert the number that was passed into the function. If you want to remove the last digit from it.
So I thought that's what I was doing here.
Well, this one, you were storing the last digit in digit so you could use it for the checks. But here, you're actually modifying your number so that on the next iteration, you're not using the same digit over and over. You're using the next digit.
Okay, lost.
So here, oh, you got
What
it.
did I say? Num divided by 10?
10, exactly. Perfect. Yeah, sure. Let's okay, yeah, you're writing some code over here. Yeah, all right. What's this array for? Okay. So left is going to be an integer and right is going to be an integer. So let's say left is 30 and right is 70. We want to iterate from 30 to 70. So we're going to be using left and right to initialize our for loop. So basically, if you want to go from left to right, you want I to start off as left, and you want I to iterate until right. So if left is 30 and right is 70, that means that I will start off as 30 and that you'll run this for loop 40 times until I becomes 70. So on the first iteration, I is 30. On the next one is 31. On the next one is 32. On the next one is 34, all the way up to 70, just for example. And then as far as initializing the output array, you just want to initialize an output array. So just like that. Yeah, so this is the output array we'll use if we do encounter. So the numbers that we're actually checking is I. Yeah, so when we do like if is self-divisible, we're just checking if I is self-divisible. If I is self-divisible, then we push I onto our output array. You could go ahead and type that code if you want. Give it a shot. So on the output array, or on every array in general, you are going to have a push method. So if I is self-divisible, then you want to push I onto output. Close, close. So in JavaScript, you just want to do, so we have our output array. We want to do something to that, right? What do we want to do to it? We want to, so let's just say I is 30, right? And we want to push I onto here. We want to push 30 onto there. And then say like we do another iteration and I is 35 and we want to push 35 onto there. We also, right here, we want to, so we just want to push, so we want to push something, and what do we want to push onto it? We just want to push, we only want to push I if I is self-divisible. So if I is self-divisible, we just push I onto our array.
Okay. Yep. So that's what the self-divisible does to verify if it's correct.
Yes. So self-divisible, we're just passing the number into this function. So if I is 30, we pass 30 into this function. That's the same as this num. Because up here, we're actually executing the function. So this is where we're executing the function with each I. For example, if left was 30 and right was 70, the first I that we passed in would be 30. The next one will be 31. The next one will be 32. The next one will be 34. Next one will be 35. And we keep passing it in until we get to I equals 70. The last one would be 70. And if ever we pass an I in here and it is divisible, like 33, 44, 55, those would all be self-divisible. And so they would come back as true. Yep. And then that's actually, this function's done. Yeah, let me actually take these out. You want to initialize that as an empty array. Run your loop from left to right. Check. If it passes, push I onto the output array and then return it. All right, yeah, so this function is good right here. And then you just have this one here. You want to convert the number that was passed in to a string. So let's say you have 30 was passed in. You want 30 to be converted into a string. And so what I would do is I would initialize a new string. So like stir, for example. And so I would take the number that was passed in and I would run the toString method on it. Yeah, if you run toString on the num, it'll convert it into a string. So I would create a brand new variable here and run the toString method on num. If if you run toString on num and assign that value to your new variable, you should be good to go. How you doing, Liz?
So I put the results.
Not result. You don't want to overwrite our array.
Oh yeah.
You just want to create a new string. To initialize a new variable, you use either let or const. Yeah. And then since you're creating a string, I would use an identifier or a word that clearly represents a string. I would typically use str instead of first val. First val makes me think. Well, I mean, instead of first val. Because first val, that communicates to me number or integer. That would work. That would work right there. Let's just replace first val with stir. So we know, like, all right, we're creating a new string. Pass the number into the string object, and you should be good to go. Another way of doing the same thing would just be toString. So num.toString. The way you're doing it, that's functional. This is object oriented. They both do the same thing. Yeah. Yep.
Yeah, because my thing was going to be toString. Okay,
So in your case, you're checking if digit is equal to 0, and you're checking if the original number is not divisible by our digit.
Am I doing or?
Yes. Exactly.
Wait. Now let's move on.
This is like the core logic right here. If you do, is the original num divisible by our digit? That's what you're That's what you're checking right here.
So wait.
So one of the checks is where. Yeah.
Digit is equal to 0.
Yeah. So one of our checks is just checking to make sure our digit is not equal to 0, and the other one is checking to see if our original number is divisible by our digit.
Is divisible? No, it's not.
If it is divisible. Yes. You actually made a really good point to look at the way that the problem writes it. So like if you look over on my screen, on the problem, it says, for example, 128 is self-dividing number because 128 modulus 1 equals 0. So this would be our original number. This would be our digit.
Modulus again.
Yep.
So then my ternary here maybe would not work. Or would it?
So this would be,
Well, I just commented this out, but I was doing a little practice ternary.
yeah, you don't need the ternary.
So cute, huh?
I like them too. They're so much easier. And here you want to do equals 0. So if our original num modulus digit equals 0.
Right. There's no integer.
Actually, it does not equal 0. Sorry. If it equals 0, it is divisible. If it doesn't equal 0, it's not
That's
divisible.
where we get the not divisible. Okay.
Yeah. So if at any point our digit is 0 or our digit is not divisible by num, we just return false. This number is not divisible, so we just iterate to the next one up here in the loop.
Do I need the else?
You do not. You do not need the else. Nope. And then, yeah, that basically looks good. Oops.
Okay, so up here, I kind of got the basic stuff, but
Left, right.
half listening to.
Oh. Output. You have your output. Dot push. Okay. So.
But there's obviously some stuff missing.
Yes. So check if. Just put the brackets. Yeah. So now you just want to check if I is self-divisible. So you have a function down here to check that. And the number that you're passing in every time is I. So if this condition returns true, then push I onto your output array. So if this condition is true, then I is self-divisible. And to see if that's true, you're using this is self-divisible. Whenever you see a function that says like is something, it's probably gonna return true or false.
So do you literally just put that in there?
Yeah. Yep.
Yeah. I was like, wait, that could never really. Like, what do you mean?
Yep.
It's just like saying if that exists.
What number do you want to pass into it? Because you do have to execute the function with a different number every time. Because you're going from left to right, right?
Yeah. Okay.
So
Do I then?
what number do you want to pass into is self-divisible every time?
Num. I'm guessing.
No. No. So, well, yeah. Technically, yes, you're passing num into the function, but down here is your function definition. So you're actually defining the function and what it does. You're passing a number into it every single time you execute it. Here, you actually have to execute it, and you have to pass a number into it. So what's the number you're passing into it? Is it left? Is it right? Is it I? Is it output? It's one of these variables.
Well, it wouldn't be output because output's the entire array.
Exact. True.
Okay. So then, well, I represents the number.
Yes. Exactly. And then if I is self-divisible and we want to push all divisible numbers onto our output array, what are we pushing here?
Pushing I.
Exactly. Perfect. Does that make sense?
I is the number. Yeah.
I is the
Start
number.
to like lose like.
Yeah, so if left is 30 and right is 70, then I is going to start as 30. We're going to pass 30 into there. 30 is going to pass in here. You're going to execute this whole function on 30. So the first digit would be 0. The second digit would be 3. And you test it. Since the first digit would be 0, you just return false. 30 is not divisible, is not self-divisible. So you'd increment I to 31, and you do it again. 31, 32, 33. The first one you'd encounter that is self-divisible is 33. So you pass in 33 into here. Our original number would be 33. Num would be 33. Our first digit would be 3. Then we'd convert number from 33 to 3 for the next iteration. Digit is not equal to 0. Original num modulus digit. Original num modulus digit equals 0. If it didn't equal 0, we would return false, but it does equal 0, so we do it again. Now num equals 3. So digit equals 3 again. We convert number to equal 0 now, because 3 divided by 10 would be 0.3. Math floor would give us 0. So this is the last time we're running this loop. Digit does not equal 0. Original num divided by digit does equal 0. So this is also false. And that's the last time we run the loop. Num now equals 0. Since we made it through this loop without returning false, we return true from this. And we push I onto the output. So the first one we push on would be 33. If left was 30 and right was 70. So that should run. Let's test it out. Result is not defined. Oh, you have a...
Oh, it's an output.
yeah. Cool. Cool. 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 15, 22. Perfect. Yeah, that works. That's good. Let's make sure the second one is right too. 48, 55, 66, 77. Perfect. Cool. How are you doing over here? You have the beginning done. We have like a couple more minutes, so I'm gonna go ahead and type this code out for you. And if you have any questions, feel free to just ask. So what we're doing here is we're converting the number to the string. We're passing the number into the string object. So this stir is now a string representation of the number. Then we want to iterate over every character of the string. And so what we're going to do here is we're just going to say for, we're going to do it like a for loop. So for each character of string. So that means if there's like, let's just say we pass in 1,244, then there'll be 4 characters. One will be 1, 1,244. The second one will be 2. Third one will be 4. Fourth one will be 4. So we'll iterate over each character. Pass that in. But if we want to divide our number by the digit, we can't use a string. And so the first thing we do is we just create our digit by converting it back into an integer. So we take whatever character, whatever is our current character, we parse it as an integer, and now we have our digit. And then the logic is the exact same as Liz's here. We go ahead and run this right here. Just instead of original num, we could use our num, because we're not actually modifying the num like we are in Liz's solution. Liz is actually modifying, chopping up the num. Here we're not doing any modifications to the num, so we don't have to use an original num variable. We're able to just use the original num variable. And then, yeah, that should work right there. Let's test it out. Result is not defined. Oh, same thing. Oh, output.push. Oh. Yeah. There we go. 1, 2, 11, 12, 15, 22. Cool. Perfect, perfect. I'm going to go ahead and show you very, very quickly, actually as quickly as I can while not moving too fast. I'm just going to take Liz's function here, the one where we're checking if one is self-divisible. And so this is the one where we do the pre-computation. So basically I'm just iterating from 1 until 10,000, because if you look at the constraints of our problem, the least left can be is 1, and the most right could be is 10,000. And so what I'm going to do is I'm going to pre-compute every available self-dividing number. And to do that, I'm just going to create a array called pre-computed self-dividing, which is going to give me access to every single number from 1 to 10,000 that is self-dividing. So I'm just going to have a record of everyone that's self-dividing. I'm not going to have to figure it out on the fly. And then I'm going to iterate from 1 to 10,000. And I'm going to check every single number from 1 to 10,000. And if self-divisible, I. So if I is self-divisible, then I'll just do pre-computed self-divisible dot push I. So I'll push that I onto the pre-computed self-divisible. And so at the end of this, I'll actually have, let me go ahead and console.log this really quickly. I'll console.log pre-computed self-divisible. Let's see what we get here. So if I do node 3, and you could see, so I have every single number that's self-divisible by itself. So I have all of these plus 239 more. Which isn't too many. What's this, 10 by 10, so probably 100. So we have like what, about 350 altogether, maybe like 300 to 350, which isn't a lot at all. This is now a constant. Yeah, we know this is going to be 350 every single time. It doesn't vary based on what's passed in left and right, so this will turn our computation into O of 1. So now, all I have to do here is I just return pre-computed self-dividing. I filter for each number in pre-computed self-dividing. I just check if the number is greater than or equal to left, and if the number is less than or equal to right. If it matches this condition right here, then then it's in between left and right. So I'm basically going to take all the ones that are self-dividing, and for every single one of them, I'm going to check, is it between left and right? Let's say left is 30, right is 70. I could see right here, those are the ones that are going to end up in the array. Anyone that's in between, though we're still going to iterate over all 350, we're only going to return true for those ones. Because let's just say we're looking at 33. 33 is greater than 30, and it's less than 70. 36 is greater than 30, it's less than 70. But when we get to 777, it's greater than left, it's just not less than right. And so it would return false for that condition, and we wouldn't put that. But okay. Let me test this out, see if it works. There we go. Yep. Same thing. So this is the solution I would definitely go with, especially like working for a company or working for myself, because I know worst case scenario, I'm only going to have to do 10,000 computations. I'm only going to have to do those 10,000 computations one time. If you code it up the way that David or Liz, you coded it up, it could be worst case scenario 10,000 of n every single time. And if you're doing this 1,000 times a day, it's like, what's 1,000 times 10,000? You know, it becomes like a ton of computation. But if you do it 1,000 times a day with this solution, it's 1,000 computations. Yeah, so much better here. Yep. Cool. So we're a little over. That's okay. Does anyone have any questions before we pop off?
Yeah, I have a quick question about
Sure.
it's 190 and
What do you mean with and without the debug?
When you go to File and Run, there's something called Run with and without debug. I'm wondering if that was the thing I was supposed to use to figure out the output of the functions.
You can't.
You couldn't do it while you were here. Is that what
Yeah.
you mean? I think it might just be because we're working off like a browser version and not actual VS Code. I don't know if Jim, if that makes sense.
Yeah, that could potentially be it, but even still, you should expect to see an output from a function regardless of whether you use the debugger or not. Yeah, just with so if you are not using the debugger, you could go ahead run it into your command line and just run the program and yeah, and you'll get the output here. Now, if you're using the debugger though, you have to like mark where you want to start debugging and where you want to end debugging. And then if I go ahead and run debug, then I actually have to, it's going to stop my code from running. And so if I want to actually step through and reach the output with debugging, I have to step over. I have to press this button until I get to the end of the function. So I'm literally walking through this function one at a time. I wouldn't do it with this problem though, and definitely not number 3, because I would have to step over it 10,000 times.
Right.
You know, so yeah. Yeah, but you should get the output regardless of whether you're debugging or you're just running it in the command line. I'm actually running it in the command line, so when I go and test the code, it's wise just to come back to Discord and look at my screen as I'm testing the code out. Yep. Yeah.
Yeah, I tried to open a console and it like stopped me because it's not like my VS Code.
Yeah. Yeah, some people like to actually code in their own code editors for that reason, but I like coding with people, so.
Yeah, when I opened my own VS Code the other day, I was like, eh. So like, I like this because you can see everything everyone's doing live.
Yeah, I agree.
Alrighty.
Cool. For sure. Enjoy the rest of your night, everybody. Hit me up anytime.
You too. Alright, we'll see ya.
See ya.